You can start now, right? So good afternoon, students who are come live for this this live session. So I hope you enjoyed the course. We're almost end of the course, right? So I hope you enjoyed the course and learned something new. So I'll be happy to answer your questions or any doubt you have about the course, about the technical content, or any other aspect related to the course. Okay. So I'll take questions. So I'll request you to type your questions in the chat box, both in Teams live session as well as in the YouTube live sessions. And I'll take questions one by one. And then once there is no further questions, we'll just conclude the session. So we have shared some link. I'll start those questions first. So Jyotsna Nagela asked a question. What is the which of the following statements about translation validation of HLS for a given input is correct? In statement 1, guarantee that HLS is bug free. Guarantee that error in translation will be caught. The statement 2 is correct because once you give an input means one C program to HLS, it will give you an RTL. Right? So RTL it can be Verilog or VSTL. And then what this translation validation does, it just check whether this translation from C to RTL is correct or not. Right? So what it does, it basically checks the equivalence between the given input C program and the Verilog that you have obtained from the HLS tool. Right? So if there is any bug in this translation, right? So then it will be caught by the translation validation. So that means your statement 2 is correct. There may be some other bug which does not occur. There may be some other bug in the HLS which does not occur in this translation, right? So that won't be caught. So it does not guarantee that the HLS tool itself is bug free. There may be some other bug which does not occur in this translation, but it guarantees that whatever the Verilog you obtain from the C code is functionally equivalent to the C program. Right? So that way, your this translation is checked. Okay, so your statement 2 is correct. Parth asks one more questions. What type of questions will be asked like from assessments or other than it? Because as per review, more questions from Verilog lecture is being asked. Please answer. Yeah, there will be no question from Verilog. First, let me clarify. And the questions that will come in the final exam will be similar to the assignments that are given in every week. More specifically, whatever the topic is covered, the questions will be all technical and directly from the topic that I have covered. But you can trust me, the questions will be very straightforward. And if you attend all the lecture of this course and understand the content, it will be very easy for you to answer all the questions. Okay. But again, I just try to reconfirm that there will be no questions from Verilog language or any other language. Okay. So if you see in this course, this is not course on Verilog language. Right? The course is on translating a C program into Verilog or VSTL or an RTL. So I'll give questions on scheduling, allocation, binding, and then all the advanced topic that I have taught in the second part of the course, like optimizing C code for efficient RTL generation, then all the optimization available in HLS, and then this translation validation, verification, security, and this physical synthesis and logic synthesis. Right? Whatever the topic I have covered in the second part, questions will be all will cover all the topic that I have taught in this course. Okay, so you do not need to worry about the Verilog. Yes,
hello.
Pratik. Yeah, Pratik, tell me.
Getting said, Verilog of high level synthesis, FPGA technological mapping, and security designing, high level security cryptography, resource allocation. C code will be asking question or not, sir, in that part.
In this course, I have taught one aspect of secure HLS, secure RTL design through HLS, right? And if you remember that part of the course, how do you basically lock your RTL, right? So question will be asked only for that topic. that how can you generate a locked RTL code through HLS. And if you remember in the course, I have taught about this locking operation, locking constant, locking conditions, right? So I might give some questions where I give a C program and I say, you try to lock this with this key, what is the locked version of the program, right? So something like that questions will come. So whatever the topic I have covered, you just follow it. No extra questions will come from anywhere else. Okay. Let me just check if there are any other questions.
FPGA
Yes.
technological FPGA technology mapping resource allocation. HLS Vivado will be asking synthesis question.
So I request you to follow the course content, right? Instead of asking here this kind of questions, I request you to check the course content and you follow those lectures. That's all, right? So you will get whatever the topic I have covered. The questions are from each lecture. There will be questions from each lecture. Okay. So let me move on. Soham Das uh, asked me the question, missed the last session, where to find the live session recording? Any help from the backend? Any input? So he asked that he could not attend the last session. So where to find the recording? So can you give the link here itself? Okay, so we'll give the link of the recording here itself in the chat. Okay, so I think of that will solve your problem. So ask one more question. What kind of project we can work upon from our end? Yeah, it's a good question. I would suggest you take many applications, right? Specifically, you can think about application in cryptographic applications or say machine learning applications, image processing applications. Those are the data nominated applications, right? And for them, HLS will work well. So you can take any applications, right? So and say let's say an image processing application like edge detection, Sobel algorithm and all, right? I'm taking a very easy example. And you do synthesis with HLS and get the Verilog, okay? And see what is the area, what is the timing, what is the latency or design obtained. And then you try to apply the optimizations which are appropriate for the design, like say loop optimizations, array related optimizations, data flow, and see what kind of improvement you're getting in terms of area or say latency or time, right? So I would suggest that can be a good exercise. And the domain that you can consider is image processing, machine learning, and uh, cryptographic algorithms, right? So there are some algorithms, if you are aware of that post-quantum cryptography, there are 4 shortlisted now. So NIST is performing that, right? So you can take those applications, those are written in C, and you can try to get the RTL directly from those C behavior, right? So that can be a good exercise, and you will see a lot of struggle there. Right? There are many construct on the program written in C that may not be directly converted into Verilog. So you need to do little kind of pre-processing of the code so that say you have to remove these dynamic memory allocations, or say the this scanf, printf, those kind of system calls, and also those we have to remove, and then you have to make the code HLS friendly. Right? So that can be a good exercise. One more, so the link for the previous session was provided here. So Soham, you can go ahead and check that. So Soham asks one more question for AES 128-bit. I have already worked upon on VSDL. So if you're an expert on electronic design, so obviously the design that might you get directly writing it in VSDL may be optimized one, right, or the best one. But I can tell you, my student here in IIT Guwahati, they also take the AES 128-bit C design and developed RTL, and then they apply various optimizations, and we are able to optimize the design quite a lot. Right, so it's kind of a trade-off. How much time you want to spend writing the code in VSDL, directly in VSDL or Verilog, or how do you want to use HLS to generate Verilog, but spend some time to make sure that your generated designs are efficient, right? So it's a trade-off between this. Either you write your RTL directly or use HLS with a smart application of the optimizers. Okay. Yeah, then I'm happy to know that Soham has also, you have mentioned that you have implemented the ES 128-bit and also verified using two keys for encrypting and decrypting. Right? So that's good. So I think you are an hardcore electronics engineer. So that is a good practice or exercise you have done already. But now I can suggest you that you do the same thing, that you will get this AES implementation in C, right? You will you search in internet, you will get it, and then you use Vivado or VTS HLS and generate RTL, and you compare the area or performance of your directly written VSDL versus HLS generated RTL, right? So that can be a good exercise, and then you'll see how HLS is performing in context of this automatic conversion, right? So it can be a good interesting thing for you to explore. So I hope this answers one question. I don't see any chat questions. No questions here in Teams, and no further question in YouTube as well. So I'll wait maybe for any other questions from you people. And if not more, maybe I'll just conclude this live session in 5 minutes. So please feel free to ask any kind of questions. So and also probably you know my name, and if you have any other doubt or any other kind of technical help is needed, you can always write me an email, right? I can always, I'll be happy to answer your any doubts. Okay. So you can type my email here if needed. I just type here. I can type in Teams. It's basically C Karfa. This keyboard is not working, right? It's fine. Otherwise, I'll just mention it. It's okay. So my name is join again. Teams meeting is no, it's okay. It is coming now. So my ID is C Karfa IITG SE.in. You can take a note of this. So feel free to ask. You can send email to me if you have any questions about this course or technical content. Okay. So I mean, please post your questions. If I am not seeing much activity from other end, so I'll conclude this meeting in another 2 minutes. So please feel free to post your question here if you have any. If I'm not seeing any other questions, I will conclude this session. And again, I want to thank all of you for attending my course. Hope it was, yeah, it is useful for you and you learned something technical new thing here. Uh, So this is a live interaction session. Unless there is queries or questions from your side, I don't understand if you have any doubts or anything, right? So I'm not going to teach anything here, right? It's going to answer your question. So please feel free to post your question here in the chat, uh, and then I'll take one by one. Vaibhav, written, yes, sir. The course is very interesting. Thank you, sir. Yeah, thank you for your appreciation. It means a lot to a teacher when student appreciate the course. And so although I have not in the course give any direct demo on the tools because it depends on the availability at your end. So I'll strongly recommend all of you to download any HLS tool. There are some open source like Bamboo HLS or LegUp HLS tool. Those are open source and freely available. And in the industry side, as far as I know, this VTS is student version is free, a trial version, so you can always download and try. But I'll strongly recommend all of you don't go by my words, just see the theory, but you take certain example as your Sohom I was suggesting Sohom that you take certain applications, you try to synthesize, then only you learn a lot of practical things, right? So learning theory is one thing and using theory in practice is another aspect, right? So I'll strongly recommend all of you to take at least one or two big example, not 5-10 line of C code, big real applications and try to synthesize into hardware through HLS, right? Whatever the tool you have. So that will give you a lot of exposure to the practical aspect of using the tool. Soham mentioned that licensing problem, but I think they have a free version also, which has a limited feature. Some features are not available, but I know uh, it has a student version, which you can check in their website and you can download and use it. Obviously, the commercial version, the full-fledged version, you will not get for free because that is their business, right? But uh, and even in your college, if you have bought any FPGA board, most of the engineering college have FPGA board for digital design laboratory and all, right? So once you bought this, all these softwares are free. You just contact your department or institute. They must have, probably this tool is not being used because it is not that popular in the student community. But if you bought FPGA boards from Xilinx, they provide this Vivado HLS for free with that board, right? So you can utilize that. So I mean, my students are using that version only. Whatever our institute bought FPGA board for our digital design course in IIT Guwahati. Sri Chinmoy has written one question is, sir, we'll get some same model questions in the final as the week assignments question. Yes, I have already answered these questions. Yeah, it's yes. I mean, the way I have set the assignment questions, the NSEM questions will be similar. Okay. So to clarify it further, all questions will be directly taken from the course content. There is no experiment I have done in preparing the NSEM questions. So if you have gone through my videos, submitted your assignments, you should not be worried about the final exam, right? It will be straightforward for you, right? So the questions, as you understand that, say I'll give some There will be some questions, 5, 6 questions from scheduling, where I'll give a graph and I'll ask you what is, if you use say list scheduling or say force directed scheduling, what will be the schedule of this node here and there and all those things, right? So similarly, I'll give some schedule and ask you to identify the minimum number of register needed for that. Some questions on that graph coloring part, how many colors is needed to color the graph, which is equivalent to need number of registers, right? Left edge algorithm, which I have covered for register allocation. Similarly, there will be one to few questions on data path and controller generation. So I'll give, say, probably I'll give you one information about the allocation, binding, and schedule, and I'll ask you what could be the good data path, right? So those kind of questions will come. In addition to that, questions will be cover all the topic that I have covered in the second half of the course, where I talk about these optimizations of HLS or optimizing C code for HLS. So there will be some examples and I'll ask you if I apply this, what will be the modified version of the code, right? So similar to this, I've also covered the security aspect. So there will be some questions that if you want to log this code with this key, what will be the logged version, right? So these kind of questions will come, and similarly for this standard verification part. Right? So all this topic, whatever I have covered, there will be questions, 1, 2 questions from each topic. So don't worry, it will be similar to the assignments that I have provided weekly. I hope this answered Chinmay's question. Okay, so you please post your questions. Otherwise, I'll leave in a couple of minutes. That can you provide codes for, so Prabhat Singh asks a question, can you provide codes for PD engineers? What is PD engineer? I don't know. Can you please specify what is PD engineer, if you don't mind? Physical engineer. Okay, okay. Yeah. Yeah, so see, if you look in the NPTEL, I have checked, there are some course on this electronic design automation side. Right? If you see, there is one course by Professor Kamakoti from IIT IIT Chennai, Professor Pithiranjan Panda from IIT Delhi. They have some course already exist on this electronic design automation. So, I mean, I don't want to repeat course here, right? So, what I found, this high level synthesis not covered in that that extent in any of the NPTEL course. So I just uh, uh, try to develop this course. But physical design course there will, so there are some course exist. I'll suggest you to just see the available course list, and you will find some courses. I have already checked. There are courses on this physical design. I mean, I hope you mean physical design by this physical synthesis part, right? So there are course available, right? I'll request you to go through the available courses and you can audit them at least. So there is question from Pratik that path-based scheduling and force-based scheduling difference. So they're completely different, right? So path-based is what? So if you see the way I have taught in the course, that this path-based scheduling is and force-based scheduling, if you try to, let me just explain. So once you have a C behavior, you can actually consider that as set of basic blocks, right? So in the basic block-based scheduling, what happened? You take one basic block at a time and you try to find the best schedule for that basic block, right? And if the program has n number of basic blocks, you find the schedule of each basic block individually and then combine the schedule and you'll get the schedule of the complete behavior. and that is called the basic block-based scheduling. And most of the scheduling algorithm follows basic block-based scheduling. And then force-directed scheduling is one of them. On the other hand, in the path-based scheduling, it is completely a different concept, where what you do, you identify the paths of the program in the sense that, and then you try to schedule the paths individually. So if you now think about there are two paths, there will be some overlap, and then you combine the paths to get the complete schedule. Right? So it's a different concept, but they are completely different, right? So force-directed scheduling is basically a basic block-based scheduling algorithm. Path-based is basically where you take more than the path starting from is kind of longest path. If you go a little bit more technical, is basically you just put breakpoint in the loop starting point and the start point and end point, right? Any path between these points are the longest path, and you schedule them individually and then combine, right? So these two are completely different. And in the force-based directed scheduling algorithm, it's a least scheduling algorithm, right? So where you calculate some kind of force, basically, if you try to schedule an operation in a particular timestamp, it will impact the schedule of other operation associated. So, and that is the compared with force, right? And you calculate the force of scheduling an operation in a particular timestamp, and based on that you decide some force will be decided, and the least scheduling always go by certain priority, and that will determine the priority of the nodes, and then you schedule, right? So that's the difference. And the multi-port binding is a completely different thing. Let me just explain. In the hardware, what happens? So whenever you have, say, uh, 20 registers, so they can be placed individually in 20 places, right? Then what will happen? Your interconnection will be messy. A lot of wires will be randomly connected here and there. Okay, so to avoid that, there is a kind of a concept where that you basically bind a set of register into you group a set of register into a kind of a bank, right? You think about, you are putting those registered in a register bank where there are a set of registers are there. So as a result, your random connections will be removed. Now you have only a single bank, and all the a function unit that are getting data from those registers will be connected to the bank only, right? So the number of wires will be very less. But now the problem comes here that now earlier, if there are 10 registers, you can access all 10 of them at a time, at a clock. But when you put all those registered in a bank, it depends on number of port that particular bank have, right? In a hardware, usually we consider a single port or dual port, right? So now the problem is that once you try to access those registers, only one or two of them can be accessed. So then what is the problem happening? Earlier you can access all 10 of them. Now only two of them can be accessed. So this multi-port binding problem is that how can you club these registers such a way in a bank such that the number of access is always limited by the number of port available, right? So it is not that you arbitrarily club all the register into a particular bank, because that will be violated by the number of access to the registers. You know already how many registers will be accessing which clock. So based on that, you have to decide which of the registers can be put together so that the number of access to those registers in a clock is always bounded by the number of port available in that particular bank, right? This is a high level multi-port banking problem. I hope this answer your questions. So there is questions here. Sam Sundar, how HLS used in design of graphics card like NPDM? I mean, to be honest, I don't know. I do not work in NVIDIA, right? So I don't know whether what is the specification of those graphics card. If it is the specification in directly in Verilog, then you cannot use HLS. But if your specification can be written in high level, right, in C, C++, or say in Python, then there are HLS tools which can convert them into hardware. But it depends on how your specification available for those graphics card. I hope it answered Samsung's question. There are a few more questions from Pratik. Phase-wise verification in HLS, attack on RTL locking. Are you attending my videos? These are all there in the video, right? I'll suggest you go through the videos, right? So just to clarify what is phase-wise verification in HLS is, so HLS has sub-steps, right? It is first pre-processing, then HLS scheduling, then allocation, binding, and then data path control. And so if you try to get the Verilog and see, and you try to so the equivalence, it's a difficult problem, right? Because it's kind of you have an apple and you have a chicken, you try to compare, right? So they're not comparable. Verilog and C have a complete different semantics, how they works, right? So what I've taught in the course is that one possibility is that instead of directly comparing C and Verilog, which is a difficult problem, you verify the phases of high level synthesis, right? So you take the pre-processing, that means you have a C code, and then after pre-processing, you have another C code or a intermediate version, and where a lot of compiler optimizations are applied, you verify, right? Then you have this then you have this scheduling, where you basically decide the time step of the operation. Then you do verify whether your scheduling is correct, in the sense scheduling does not violate the data dependency among the operations by scheduling the operations, right? So this is something the scheduling verification. And then in the allocation binding, you just try to verify whether after variable map to registers and the number of registers is much lesser than this these variables, the functionality does not change, right? And similarly, in the data path and controller generation, you check whether the data path actually performing what is intended to in clockwise, right? So this is the phase-wise verification, and that is something is sometimes useful if you have that intermediate data. But sometime in a commercial tool like Viva HLS, they may not give you those intermediate information. So then this phase-wise verification does not work, right? So once you have this intermediate information, like information after pre-processing, scheduling, and then allocation, binding, and so on, then you can only apply this phase-wise verification. Otherwise, you have to go for end-to-end verification, which is a challenging problem, but there are solutions, right? So I have talked about one of the solutions in this course. Okay. So see, Pratik, you just copy paste this topic here. It's not something that you copy paste the topic and I'll discuss everything here, right? That is not the purpose of this session, right? You just copy paste the topic from this course and pasting here. What does it mean, right? I have already talked about what is attack on logic blocking. You watch the video, you get the answer. When if you have any specific questions from RTL logic locking, I'll be able to answer here, right? So that is the purpose of this live session. There is no point discussing what is RTL logic locking when the video is available with you, right? So, and similarly, this recent advances in C-based VLSI design or no. Please go through the video, you'll get your answer. You ask specific questions from any topic, right? Then only I can able to answer. I mean, there is no point discussing all the topic that I've covered in the whole 4 months here. So I'm not going to answer all this topic that you're copy pasting from the course content, right? So you have to ask very specific questions, which you have doubt, which do not you understand. Then I'll be able to answer your questions. Otherwise, I'll not. I'll ignore this kind of top level copy paste question. Okay, so I'll again. If you have any questions, please feel free to ask here, and I'll be happy to answer your questions. But I request you ask very specific questions about your doubts, right? Instead of asking a high-level topic questions. So I'll wind up in another 2 minutes if I do not get any further questions. Rohit asks one question: as the course is proceeding, I am facing problem solving assignments. But we are providing the solution as well, right? So if you face a problem, I'll request you to see the solutions, and sometimes you also give the when I have also we are also giving the solutions and explanation, right? So we do provide the explanation of some difficult questions or little bit tricky questions. So I'll request you to just go through them. And if you do not understand a very specific questions or the solution, you can always post a question in the forum, and I have 4 TAs who will help you, right? So don't shy about your if you do not understand something, you can always post your questions in the forum, where if my TAs, teaching assistants, or myself itself will answer any questions or any doubt you have any of the topic. Okay. Okay, so I think we can wind up now. Thank you everyone for joining these live sessions. I appreciate your time. Also, I appreciate your effort attending my 30 hours long courses and spending time learning this course. So I want to thank everyone for helping me in successfully conducting this course in this online mode. And I wish you all the best in future. And also, I wish all the success in your future plans. Please feel free to contact me for any technical reasons. Obviously, I'm happy to help you. You can reach me over my email, which is specified in the chat box here, as well as it is available in my website. Thank you, everyone. Bye.